Hello and welcome to the Mastermind, Body, and Spirit Show. I'm your host, Matt Belair. Today's guest is the founder of the Bijective Research Methodology and director of Bijective Physics Institute. He has published around 70 articles and 10 books on physics, cosmology, integration of life, and consciousness into cosmology. We're going to talk about black holes, the Big Bang Theory, consciousness, and so much more. Welcome to the show, Amrit, Srechko Šorli.
Good evening, everybody. Good evening.
I'm so glad to have you on. We've had a few discussions. They were short. They blew my mind. We had a little bit of a technical difficulty getting you here. You sent me an article, or one of the published articles on black holes are the rejuvenating systems of the universe. So, and we were having a discussion before we jumped onto this podcast here about some of your work and the things that you've done. It is incredibly dense, very fascinating. You're sharing you've been studying physics for 40 years. So I'm going to be quiet now because I'm excited to finally be here and have this all set up for you to share your work. But why don't you tell the audience a little bit about who you are and how you got to where you are today?
Yeah, thanks, Matt. Thanks for inviting me. So when I was 10 years old, this new idea came of Big Bang cosmology. Now, before there was a stationary model of the universe, and then I was talking with my grandmother once. I say, "Listen, Mom, there is a new theory about universe now," and she say, "What?" I say, they say that universe has exploded out of nothing. And my grandmother say, "This is silly idea. This is stupid." And my grandmother, she never sees seaside. Let's say she was born in the mountains inside in Slovenia, and she was living like say on the diameter of 30 kilometers. She was just there, and she had 4 years of school. She know how to write, and that, she was not high educated. She didn't have PhD in physics. So I was a 10 years old boy, and I also feel it, that this Big Bang theory, it's quite silly, the idea, but I didn't know why, but I feel it inside, that when I was in the night outside, and when I was seeing this beautiful, immense night sky, I couldn't believe this could just start from the mathematical point. So when I was growing, as a young boy, I read all the possible books about physics, astronomy, mathematics. And then I graduated engineering. And then I started studying physics, psychology, philosophy all together, because I was very curious mind, But then I've seen it, that actually professors which have been teaching us at university, that they don't understand really the subject. They are just teaching us something that they read in the books, but they didn't really touch the core. My feeling was that they don't know from inside what they are talking about. So I dropped everything. They offer me also research in America, but I dropped everything and I start searching myself. And then I was reading for years books on physics. I was reading for years, on Arxiv. Arxiv is one database where you have most of the articles that have been published in physics. And I've seen year by year that actually I am understanding less, because what has happened 100 years ago with the special relativity of Einstein, that in that moment mathematics has somehow overruled physics, And today, if you have a good mathematical model, every good journal will publish it, but nobody will ask if this model has sense. Sense in the way that if this model really reflects something that exists in physical reality. This today in physics is not so important. So I developed a bijective research methodology. What does it mean? We have in set theory, we have two sets, let's say set X and set Y. And in the set X, which is representing the universe, we have a number of elements. But what I'm doing now, I'm develop a model where in the set epsilon, which is the model of the universe, we have always only the elements which have one correspondent element in the set universe X. This means that we somehow have bijective picture of the universe. This is universe, physical universe, and this is the model. And that the physical universe and the model, they are totally perfect. This is a perfect picture, you know. The first thing which we did together with my research fellow Fiscaletti, this Italian physicist, we demolished space-time. You know, we are believing for 100 years that space is a fourth dimension of that time it's a fourth dimension of space. But if you go in with the bijective analysis, you see that's not true. You know, time is only a numerical sequential order of change which happen in space. So there is absolutely nothing happen ever in time, you know. Universe is always now. And Einstein, he was the only one aware of this, very good, but maybe also Max Planck was very close. So we see the whole universe through the, let's say, through the mind box and through the time box. And the mind box and the time box are both in the head. So it happened to me maybe because I meditate for many years that somehow I'm out of the time box. You know, for me, time is just a mathematical parameter of motion in space. As I say, first we prove it that actually time is not a fourth dimension of space, and we have been working for 3 years to publish these articles. This article in Foundations of Physics. This is a quite respectful journal, and I was thinking after that, you know, this is 27 pages article. I was thinking now they will call me. They want to know. They want to develop this thing because this is very important time. It's a very important element of physics. But nothing happened, you know, because today physics actually is stagnating, is becoming quite of religion, because if you have a certain idea which is out of the established paradigm, you are somehow out of it, you are stranger, you are not well accepted. And my big love is and was Einstein relativity. This is really, I spent 30 years of studying relativity. And I managed to publish one article in a quite important journal, which is published by Springer Nature Group. This is Scientific Reports. And I published there an article with the title Mass Energy Equivalence Extension on Superfluid Quantum Vacuum. This is really beautiful work, not because I mean, it came through me. I didn't do it anything. You know, you're just somehow going into no mind, and a cosmic intelligence is using your brain, your mind, to write down something. But what is the point of this article is, Einstein did very good things, you know, but all the people which they do good things, especially in physics, they also do some big mistakes. And his biggest mistake was that the photon can move through empty space, you know. Somehow when the ether was abolished from physics, and I repaired this mistake with extension of the mass energy equivalence principle. This is this formula, you know, AMC squared, on the superfluid quantum vacuum, which means on the space, because the space is energy. Space is not empty. Space is primordial energy of the universe. And doing so, I developed actually relativity in a very beautiful way, you know. No article was published, but then some people, I don't know who, but there's some people are a little bit not happy with the conclusions of my article, because in my article, I explain what is mass as the amount of energy of the proton and what is a proton inertial mass, you know, because the proton, it's a it's a particle which has amount of energy, and its mass, the proton mass, is incorporated energy in the proton. So that's why, because the energy is concentrated here, the space it's having a certain pressure towards the surface of the photon, of the proton. And this is the proton, and this is every physical object inertial mass. But in physics, they are still not understanding the difference between mass as the amount of energy and inertial mass, which is the result of a given physical object interaction with the space. So space, it's pushing towards every physical object and giving physical object inertial and gravitational mass. And in this way, I show it very, very elegantly with the very pure mathematics, you know, that the Higgs mechanism is unnecessary complication in physics. And you know, the whole Higgs study, actually, maybe this is important to say, but you know, Karl Popper is one of the most prominent logicians in the past century, and he has developed something that we call falsifiability. You know, falsifiability of a certain model in physics means that the model might be wrong, might be right, but you can prove this, or you can disprove this. In a certain way, the Higgs mechanism is not falsifiable. It's like a kind of ad hoc hypothesis. You know, you cannot prove it, you cannot disprove it. The same is with the Big Bang. You know, the Big Bang is not scientific theory because it's not falsifiable. And I was working for so many years on the relativity, and then I sent the second article. The first article was published, then I sent the second article, and they refused it. But they didn't have a really good reason. But somehow, you know, in physics it's like this, that these old professors which are sitting in their chairs, they don't like certain things which they maybe don't understand, or maybe they are not totally in the paradigm. So I got pissed off a little bit and say, okay, so I will destroy Big Bang, because I knew it for years that Big Bang is absolute nonsense. But now I'm putting a little bit of this, my energy in this, you know, because I see that if we want to build a new physics where life will be consistent part of evolution, where consciousness will be fully integrated into the model, we have to break down this religious theory of Big Bang. And this is what I'm doing now.
Man, I had to give all of my energy and effort to follow along with that. I understood some of it. You know, I told you before we started, my physics is very minimal. I did get to go to Egypt with the Resonant Science Foundation. I went through the course that they had, which, you know, gave me an introduction to physics and some theories that exist and some that they're offering. There's a lot here that I think that is important. The first thing I want to make sure, though, what was the person's name that you said that is, you'd said it to me in private conversation as well. You said this guy's like the best physicist in the world or whatever. You know what I'm talking about? He was on Joe Rogan also. You're like, this guy is doing some amazing physics.
Oh, really?
Yeah. Do you remember? You were the one telling me.
No, I don't remember now.
Oh, no. Who do you think the best physicist on the planet is right now? Or best mathematician?
I like very much one Russian physicist. He is developing a theory of superfluid quantum vacuum. His name is Vasili. And because what happened in physics, that for 100 years, we have been believing that space is empty. Space has no physical properties, you know. And then Vasily's Bitnev and me and one Italian physicist, David Fiscaletti, we three are working on this to show that with taking physical space, with taking away from universal space physical properties, that the physics is totally lost. You know, it's like a bird with only one wing; it cannot fly. And you know, Einstein, he was extremely intelligent, but he was actually so intelligent that he was fooling the entire physical community, you know, because he developed some mathematics that was so elegant that everybody think, wow, that's it. But it was not, you know, because we have to understand the Einstein relativity, it's a mathematical theory. This is not a physical theory, you know. Let's say in Einstein relativity, you describe gravity with the curvature of space. Okay, with the geometry of the space. But Einstein, he was aware himself that geometry cannot carry gravity. This was just mathematical description. Uh, I've seen this very clearly, you know, that's why I developed now that, the mathematical description of the curvature of space actually is showing that the space has a variable density. More space is curved, less space is dense. And I developed a mathematics on that which works perfectly. Because after NASA has discovered that universal space has Euclidean shape, you know, we have to understand now that in Einstein relativity, the curvature of space does not mean curvature, it means variable density. What is variable density? You see, this is a physical object. This physical object has a certain energy and a certain mass, A mc squared. And he is diminishing the density of the space on the surface exactly for the amount of its energy. This is the expansion of mass energy equivalence principle on space. We call it also superfluid quantum vacuum. Vasili, this guy that I like so much from Russia, he invented this name. And with this, you know, you can do very beautiful things. I did all calculations why the clocks are ticking slower when you go closer to the heaviest object, when they are ticking faster when you go in the empty space. This is also a mathematical basis for the unification of gravity and strong nuclear force. You know, it's really something good. And actually, what I calculate on this basis, I calculate that on the surface of the black holes, the space, the density of space, it's so low, you know, because there is such a big amount of energy incorporated in the black hole that the atoms become unstable. This is like you and me, you know, when we are standing on the nets which has 10 per 10 centimeter, you know, like this 10 per 10, we are still stable. But if this is growing 20 per 20, we somehow still manage. But when this is 1 meter by 1 meter, we are falling through. The same it's happening on the surface of the black hole, that the space is has such a low density that the atoms are falling apart. But what I did on the basis of this mathematics that I developed, that in the center of the black hole, the density is also low, of the same as on the surface. So inside the black hole, also the matter is falling apart into elementary particles. And when these elementary particles are growing, you know, the pressure is becoming so strong that when we have these explosions of supernova, that's why stars are exploding. But on the other side, we know today that in every galaxy, almost every galaxy, we have in the center of the galaxy a huge black hole, which has a hole inside. And in this hole, it's happening that the matter is transforming into fresh energy of sub-elementary particles, which are somehow jetted out. You know, there is a huge jet out of the galaxy. You can see this sometime on pictures. So the black holes are rejuvenating systems of the universe. You know, the old matter is transformed into fresh energy of sub-elementary particles, which are somehow the raw material, the stuff out of which new stars are born. And this is going for eternity. there is no beginning, you know. Universe, it's not created, and it's extremely, the Big Bang, Big Bang is worse than the flat Earth, you know. It's worse.
I was like, oh man, I want to dive into that. Well, you a lot of that was important, and one thing that I wanted to share is just my view as like a layman, like trying to understand these deep ideas, you know, understanding physics to the degree that you do, and mathematics, and even just kind of dipping my toes in, the level of research and intelligence is very high. And one of the things that you touched on in a conversation with me and also in this podcast is that it seems to me in the research that I've done that there are institutions that hold ideas of, you know, physics or the model of the world, the model of the universe, what every person believes to be true. Religions hold certain beliefs of what is true. You know, physics and scientists have these models of the universe that they believe to be true, and they spend billions and even trillions of dollars trying to prove this model. And one of the things that you shared was they're trying to prove it and say, hey, on something that's not even like a firm ground. And that was one of the things that I learned in Egypt with the Resident Science Foundation is, I forget what it's called, maybe you can help me out, but they're trying to prove a theory, right? And then something doesn't work out, and so they basically make the math work out to get to the next step rather than
Yes.
rather than
Yeah,
recalculating, right? So
yeah,
they
yeah.
know it didn't work, but they just keep going, and they fudge the math. There's a term for it, and they said, you know, most of the theories, that's what's happening, that they've gotten so far and then it didn't work, but they were able to progress 9 other steps, but there was an error on step 2. And what you're kind of sharing is that there needs to be room for ideas that are based on solid fundamentals of mathematics and physics that allow you to get to the next step, and it needs to kind of zero out. It needs to pass, and then you take the next step. And the challenge that some of these new ideas are facing, and people like you, is you go to an institution that has a vested interest in an old idea, billions of dollars to kind of, you know, teach this way in the education system and also to promote that model. Would you say that that's accurate?
You don't say, uh, that's a very beautiful conversation, you know, because uh, we can read now for last 10 years that science is in crisis, that physics is in crisis. And what you point out why is in crisis, you know. In crisis is because today physics has become a new religion, you know. If you believe certain things, you are in. If you don't believe, you are out. Let's say few years ago, a guy called me and said, listen, I'd like to work with you certain things on this superfluid quantum vacuum model. And then we have been starting. I did some calculation. I sent him. But then he said, you know what? I can't work with you. I said, what's wrong? He said, listen, actually, I've seen that you're a little bit on the blacklist somewhere, you know? So if I work with you, when the next year, when my contract will be over, they will say, listen, won't work anymore with you. So somehow, a friend of mine who, I don't know if it's true, but anyway, I will say, who was in CERN, you know, recently, he said that I'm on the blacklist. So uh, this academic establishment of physics is not sincere enough to confront, to do confrontation, you know. Let's say I will make now very good example to be more earth to the earth, you know. A top quark, you know, we have a 6 quark discovered. 6 quark have been discovered, and the top quark is 183 times heavier than the proton. Okay, so but we know in the theory, in the standard model, that the quarks should be inside the proton. Upper quark and down quark are inside the proton, but the other 4, we don't know where they are. And then I ask on our institute, we have a good institute of physics in my country, Joseph Stefan. I say, could you please just send me some literature, some scientific articles. Where is this top quark which was discovered? They didn't answer. And then I sent a letter to CERN scientists. I said, could you tell me where is the top quark? They didn't answer. Then I sent a letter to Fermilab. They didn't answer. So they discover top quark, but nobody knows where it is or where it could be. And then I called a friend from America, and he said, you know what? I read somewhere on internet, on Wikipedia, that there might be some exotic stars, some neutron stars, where the protons are under certain circumstances could be so big that they would have a top quark inside. You know, this is just, I mean, this is not physics. This is nothing. So what they are physicists, what they are doing, if something is not working, they will cover up with mathematics, you know, and somehow, okay, I have to say this. This is very important that people will understand how this works on the case of Higgs boson. Higgs boson was discovered, okay, 4 years ago or something like this. And the Higgs boson has a mass, has a lifetime of the Higgs boson is 10 on minus 22 seconds, you know? You know what is 10 on minus 22? 10 on minus 6 is 1 million part. On 22, this is nothing, okay? So when we have what is actually Higgs boson? When we have collisions of the protons in the cyclotrons, we have a few million collisions every second. Every single second, we have a few million collisions. And once upon, very rarely, extremely rarely, the Higgs boson, which is characteristic flux of energy, is appearing, okay? Very rarely. So actually what happened when the proton is accelerated close to the speed of light, he is taking energy from the space, and his relativistic energy is much higher than when the proton is at rest. And when these highly accelerated protons are colliding, this kinetic energy, which is in the proton, is somehow creating a firework. And now in cyclotrons, they are making photos of this firework, and they are out of this are building, let's say, high energy particles physics, you know. But what actually Higgs boson is? Higgs boson is man-made artificial flux of energy. It's not particle. Higgs boson is not a particle of anything. And there is no Higgs boson in the physical universe. And the entire cyclotron physics will never have any technological application. Let's say like as discovery of electromagnetism, you know, we have computers today, we have phones, we have everything, because they discover something real. But these people, they didn't discover anything real. And what is now with the problem with the Higgs boson and the Big Bang, that the entire cyclotron physics is linked to the Big Bang, because they believe that before this magic explosion, you know, that there was a kind of supersymmetry, that all particles have been without mass, they have only energy, and then somehow a little bit later the miracle happened, and the Higgs boson, somehow the Higgs field entered existence and gave particles mass. And so, you know, this is a story, this is not a science, because the only difference between cosmology that is today in physics and cosmology that is in the Bible, it's time. In the Bible, God has made universe in 6 days, okay? According to Big Bang theory, there was a fraction of the second. But still, the Big Bang theory needs the kick from outside, you know? It needs God, creator. And I believe that now, not that I believe, I'm convinced, I see, I understand that in 21st century, that the Big Bang theory is not a relevant theory anymore, because universe is a is self-recreating, you know, it's recreating continuously itself. And universe, it's conscious. There is no God above the universe. Universe itself is divine, is God, you know. Let's say this divine quality of the universe, it's all over. I can see it all over. But if you are stuck in your mind, if you are stuck in your time box, you don't see anything, you know. This is today, that's why the science is in such trouble.
Well, you shared, I think, a lot of really important things. And I wanted to kind of draw out the example that you used about the Higgs boson, because I had actually heard about some of that research from my friend David Lombert, who had talked about how much money they're sinking into it, and basically sharing that, you know, it's not going to go anywhere because you had the idea, right? They start with the theory. They put so much money into it. I don't know how much, probably billions, something like that.
1,700 millions per year.
Yeah. So, right. And then, so then it comes up with nothing. And people like you and other people who are doing the research are like, this isn't going to go anywhere. It's just this infinite money pit that's going to provide no fruit, you know, but they had that theory. And so that's kind of one of those ideas drawn out, where if you present something that says, hey, maybe this isn't the way to go, kind of like if you're digging for gold and you know you have some sort of thing where like there's no gold there, you know that, but they keep digging and they end up getting nothing, and they just keep digging and using resources, but you have a new idea that might be able to move them over here to have more fruits or use their time a little bit better.
Yeah.
And another example that is a little bit different, but it's the exact same thing. There's a geologist named Robert Schoch, and he did amazing research on the Great Pyramid. And he discovered that the pyramid was at least 10 to 12,000 years old, because he could see evidence of the Great Flood. And he had to debate this in Egypt. This was years ago now. And the whole institution, the whole scientific institution, was against him, even though he had the actual science. He had the proof. He had what made sense, and he had to present this, but all of the institutions were against him because that's what they were taught. And rather than moving forward toward new ideas that might be a little bit more aligned, that might have a little bit more grounding, a little bit more of a sound idea or proof or a model, it's easier to continue on one that doesn't work than to say, oh crap. And if you imagine that from an institutional level and from an education level, if you're an individual who studied this your whole life and somebody presents something that's saying, hey, all of that research, you might have not had the foundation you would hope for, it would be shattering. It would shatter your whole existence. It would be very challenging. So there is that. And then there's also the money and the time and the boards and how they work in that function. So they're not set up in a way to adapt to new ideas very quickly. So, you know, some people, I think, demonize them a little bit. And, you know, there's obviously some things that aren't great, but there's also reasons why it's structured like that. And what we need are those solutions, those ideas, and those ways that we can pivot or at least support ideas and models of physics. Because when you look into physics, this is trying to explain almost the unexplainable. It's trying to figure out, you know, the most mysterious things in all the universe and prove them. So it's going to start with a theory, and we're moving forward. But the last thing that I wanted to share that I think is important is your model of the world. You know, you spoke about flat Earth, and one of the things that I learned a long time ago from this guy, Corey Herter, who I hope will come on the podcast one day. He's very fascinating. But he talked about the formula for truth. And so if you have an X and Y axis like this, you have flat Earth on the bottom and then round Earth up top, right? And so if you're round Earth and somebody's going to come at you with flat Earth, you might say, oh, that's baloney, I'm not going to listen. But really, if you listen to every single thing that they say, there's 45 degrees of information. So you just listen. It doesn't mean you need to believe it. All you're doing is you're listening to that point of view, because there might be a nugget of information there that was useful to the theory that you had, and you're able to share in a more co-creative way. You both get more information that way. And so when we're talking about world views, one of the fascinating things I think from studying hypnosis and looking at history, looking at education and what we're taught, you know, they teach in America that Columbus discovered America. Then alone, there was already civilizations of people that were established here with a 20,000-year history. So they're being taught something that isn't necessarily true. So it's really hard to know if your model of the world is actually correct. You can have that information to steer you, but we need to open up to more information about what true models of the world are. And the only way we do that is through listening and getting feedback and being adaptable, but not just taking ideas, but allowing that information in. And if there's a worldview or a piece of information like you're sharing now saying the Big Bang Theory, we have enough evidence saying, and this would be your house to explain this in a physics way, that we don't need to move further. Like it's just that theory doesn't work. We can spend more time over here on a theory that has more ground. And that's what we need to move towards, because it'll change the whole paradigm. If you change somebody's worldview, and this is what religion does, this is what education can do. You change somebody's worldview to a more empowering way, it can transform their life and it can transform a civilization. And
Definitely.
so you can comment on that, but one of the questions I wanted to ask is, you said something very important, and you're talking about integrating consciousness into the model of physics. And that's a very fascinating thing, because, you know, even, you know, integrating time, or saying, you know, time isn't it, or space, saying, no, space isn't empty, that we need to factor that in. And so that improves and changes the entire model and the way we see things. So I'm wondering if you can speak on that.
You know, that's what you say, that we need more information, you know, that's true. But there is one thing important also, that we have, let's say like this, you know, I'm doing physics not with my mind. Okay. I'm using my mind as a tool. I'm doing physics as a pure consciousness. So we have there are three elements in the game: me as a conscious observer, my mind, and my perception. Okay. So I'm perceiving through my senses the universe. Then these informations are elaborated by my mind, and then I have experience. But as I am fully conscious, I can directly see the universe as it is without entering my scientific mind. So I have a direct experience of the universe. But if I want to play a scientist, if I want to play a physicist, then I ask my mind and say, come guy here, we will work. What is my advance? My advance is that I am not spoiling physics with my mind. So I'm building physics, which is a pure physics of consciousness. My mind is not influencing physics. But what is happening in the physics today, let's say, there was 60 years ago a real problem, because photon has no mass, it's a massless particle, and proton has mass. So the Higgs, the guys which develop Higgs, they say must be some field which is slowing down some particles and other particles. This field is not slowing down. What does it mean slowing down? If you can look the videos about Higgs mechanism, the original idea is must be some field which is slowing down some particles and giving them inertial mass. Okay, inertial mass, it's not a mass as the amount of energy. We've spoken about that before. So before Higgs field, physics was working very good. And then at that time we had electromagnetic field and we had the gravity field. And there was a big, huge mental work how to bring these fields together. Now we have a Nobel Prize for discovery of the Higgs mechanism. We have a Higgs field, and nobody knows how Higgs field is related to electromagnetism, and nobody really knows how Higgs field is related to the gravity. So the Higgs mechanism has created much, much, much more confusion in physics than it was before, and has somehow lowered the beauty of physics because it's something that is just out of the mind, you know. And what physicists are now doing, if they want to describe something, they just pop out, you know, like when have you seen this in the circus? You take a rabbit out of the hat. Have you seen this? They are doing the same. All we need now, just few months ago, the article was published about negative mass, that mass could be negative. This is absolute silly nonsense, you know, and this article was published in an important journal, because to explain certain things in cosmology, it could be good that mass could be negative, you know. But I mean, mass is mass, you know, this is energy, this is amount of energy which is incorporated, and give it negative sign, it just makes sense. And so that's why I was meditating years and years, you know, how to give physics some new rule of searching, which will end this pseudoscience, you know. This is Higgs mechanism is pseudoscience. This is just nothing. And I came on this idea of bijective research methodology. I have a universe, and in the universe, I have different elements. I have space, I have energy, I have mass, I have change, and so on. So I decided that I will build physics where in the model of the universe, every element in the model must have exactly one element in the physical universe. This means that the set of the model, and between the set of the model and between the physical universe, there is a bijective function, bijective correspondence. And once you have such a model, then you know what is the result is, there is no possibility of mistake. Once you have 100% exact model of physical reality, you cannot make mistake. And I'm ready to talk with Peter Higgs. I'm ready to talk with all experts which they somehow think that Big Bang it's a right theory. In 1 hour, they will not have arguments anymore, because in the physics I developed, whatever I say was observed or measured. No, I'm not just inventing something out of the blue. Sure, definitely they will not talk with me, you know, because they are ignoring me. They are somehow pretending that I'm not there or here, because they cannot face the truth. As you say, there was so much money invested in this. There was so much intellectual power, intellectual work invested on this, that now today nobody is ready. Nobody is ready to say Big Bang is a false model, and the entire cyclotron physics, 5 Nobel Prizes was delivered for this, is just a bullshit. You know, there is no antimatter, there is no antiproton, there is nothing on this. There was no supersymmetry. This is just a mathematical philosophy, which physics has become. And actually, I'm pretty sure, you know, that the next generations of physicists will got that what I'm talking now. And that's why I was so happy to meet with you, because you have this power, you know, you have this knowledge, and you are the person which is somehow putting this fire in the world. Very important.
Well, you know, to put that in another way, so people kind of understand what you're saying, because it took me a little bit to understand it when I was learning a little bit of physics. Again, the very minimal amount, but what you're sharing is that for pulling a rabbit out of the hat is they'll keep moving forward with a theory, and then they'll invent like supersymmetry or anti-gravity or antimatter to fit the model that is not working. So they do the mathematics, they do the equations, they're not working. So in order to explain why it's not working, they introduce some other thing. And so before you know it, you've got 20 rabbits out of the hat, and you know, the purity of the model, the purity of the theory is just distorted, because the likelihood of all of that coming together and finding all these things is you're basing it on something that just isn't true, that doesn't work. So you need to kind of start back at square one, which is incredibly challenging to do and to understand that. So from your perspective, I want to go a little bit longer here, but not break people's brains. What do you think, like for the average person, you know, in your research of what you're viewing, you know, how you live your life, how you view the world from the physics perspective, what have you learned that might be able to like help an individual, like for their view of the world, for their model of the world, or how they navigate life here?
Yeah, you know, when I was student, I was reading a Stephen Hawking book, The Brief History of Time. This is the most sold book on the planet in physics. I think he sold 7 million or even more. And you know, in this book, he's explaining also the Big Bang. You know, and he say, before the Big Bang, in the first moments of explosions, the energy of the matter was positive and the energy of gravity was negative, and the sum of this energy is zero. But then these energies have been multiplying, like -1 plus -2 is 0, -2 plus -2 is 0, and so on. You know, I mean, to explain appearance of energy in the universe with such a mathematical trick doesn't make sense at all. But everybody was clapping. Oh, great, Stephen Hawking, great. You know, so why people are so short-minded? Why they don't see that if something is silly? This is because they don't have a distance from the mind. If you want to be brilliant in your life, if you want to be brilliant, whatever, artist, or if you are working in the woods, or if you are doing whatever, you have to be aware that you are not your mind. Because once you are aware that you are not your mind, then you become a master of your mind, and then your mind can really work for you. And what is happening today in physics, that the mind is a king. And this observer, you know, observer, it's a very important element of physics. Observer has died. Today, physics has lost the power of auto-reflection. You know, that you reflect upon what you are doing, what your mind is creating. So they are just inventing something. First they invent a Higgs field, and you will not believe, the first article on the Higgs field was refused. They didn't want to publish 40 years ago. They say this is rubbish. But then, you know, they managed to publish slowly, and then they came with this idea. This was something special before Big Bang, and that was very hot. There was supersymmetry, and they have been there. Higgs field appeared. God has sent it Higgs field. You know, God was looking, and still something was missing, and then the God say, "Oh, Higgs field, I will create a Higgs field." And you know, I mean, Albert Einstein, Max Planck, Erwin Schrödinger, they are turning in the graves. You know, they are turning in the graves, seeing this. But anyway, what you ask me, I practice every morning. I practice 1 hour. I watch my mind, and in the evening I watch my mind. You know, and still sometimes my mind wants to be a master. You know, he want to do something on his own. And definitely, if your mind will create your life, it will be disaster, 100%. That is, you know, Descartes, he used to say, Descartes, cogito ergo sum. This means I think, so I am. This means thinking is giving me security. I am, this is my identification. Now we are in 21st century. Now we have to say, I am aware of my mind, so I am. And the more you are aware of your mind, the more beautiful your life is.
That's amazing. I was writing that down. I've never heard anything like that before. That's incredible. Uh, wow. Well, for this, we're going to get you back on because I've looked at, we didn't even get into it, but touching on a little bit about, and you have papers on this. So I'm going to link people up. You can look at the papers. You have a lot of published stuff. One of them was black holes are the rejuvenating systems of the universe. And next time, I think what are we going to talk about? Like the consciousness integration into all of this?
Yeah, how the consciousness is integrated in the universe, and also how life is integrated in the universe. If some people would have interest, we have 10 articles published on this in neuroquantology. But there is one thing important to say, that when we are dealing with the physics, of matter and energy, electromagnetism and subatomic particles, we can use bijective research methodology, but once we are moving into the realm of consciousness, then somehow I developed some mathematics, what consciousness could be, which maybe is not so bad, but it is still far, far away from consciousness, because the human mind has no power to grasp the consciousness. Consciousness is ontologically something much higher. So all these theories about quantum consciousness, and Roger Penrose's theory of consciousness and so on, this maybe is only a pointer, it's only showing the way, but you have to walk yourself. So a consciousness research is more about meditation. It's more about experiencing consciousness, not about thinking. You can't think about consciousness, nothing.
Yeah, I agree. That's interesting. And I'm just, when you're talking, I'm paying attention so hard, but with your research, and if people want to dive in before we cover some of those topics, where can they find some of your work and dive a little deeper?
We have a homepage, www.bijectivephysics.com. We have a homepage. Then most of our articles are published about consciousness, are published in neuroquantology journal. And if maybe some experts would like to see this mass energy extension, then this article in the scientific reports, it's online. And recently I published also a book, the end of Big Bang cosmology. This book also is reachable on internet.
Amazing. Well, thank you for your work. It's great to finally share you with the audience. I look forward to having you back, because that's just a small taste, and I know that we could kind of go on forever, because I've looked at some of your articles and I only understand a very small amount, and I understand where you're going through it, like in those, what you're facing in the physics field. I couldn't prove you right or wrong. However, I have seen many times where there's new ideas and they're rejected just because of that. And we're spending a lot of time and a lot of money on theories that are not working, that we have enough research evidence and scientific data to know that those theories probably aren't sound, and we need to reconsider our view. And you're right in saying that science and physics is becoming a little bit religious in that sense of protecting an idea rather than adapting to new information and going with what's best, what's most sound. And we need to do that. So do you have a message for any kind of physicist out there, if you want to share some of your work or what you see in the field? Like, what could happen in the world of physics that would make you happy?
Yeah. I have a really message out of my heart. I'm sure that we will progress physics, but we have to, as I spent 2 years in India, and I was a big follower of Shiva, because Shiva is the destroyer. And if we want to progress physics, we have to destroy all the knowledge we have. Because what is the main obstacle for physics progress is that people, which they know a lot of physics. You know, they are not able to step out of the box. They are inside of the box. But once you step out of your box, then you can see that all your knowledge of physics is in your mind. Okay, this is like I'm a conscious observer. I'm here, and this is my mind. So I take this, I step out of this, and I see, aha, I have this data here, and then what I did, what I do, then I compare my data with observation. You know, let's say practically. Since 214 that NASA has discovered that universal space has Euclidean shape, all the ideas about curved space are dead. You understand? In my physics, I sleep very, very good. You know why? Because I know that the bijective physics, this is not my physics, but the bijective physics is right. It cannot be wrong because it's bijective. You know, this is something very beautiful. Because once every element in the model has exactly one element in physical reality, there is no mistake. Einstein was dreaming about this, you know, but he didn't develop that. And this is my message to physicists, you know, step out of your mind and you will have a new vision, you know, and then you will repair a little bit. We have to fix little bit mind, you know. Actually, let's say it like this. There are two dead branches of physics. First dead branch is Big Bang, and the second dead branch is cyclotron physics, high energy physics. This innumerous numbers of particles, you know, which are just not existing in the physical universe. They are just artificially made. Once we cut this, the tree will grow very good.
Mm. I like that idea. It's like pruning, you know, you move away and you try something
Yeah.
and it doesn't always work. So if you then redirect the energy towards something that might be a little bit more useful, we all win.
Matt, you gave me a good idea. I will write now article.
Okay.
Pruning physics.
Pruning physics. There you go. Cool. Make sure you put me in the footnotes.
Oh yeah, definitely.
Cool. Well, this is a great first episode. I've enjoyed speaking with you in private, and I'm glad to share a little bit of your work with the audience. Thank you for everything you're doing, and we'll be in touch, and we'll do another episode soon.
Matt, thank you very much that that you manage all this, that people can hear what I'm doing.
My pleasure. Thanks, guys, for watching.
Matt,
Talk
see you.
again
Bye.
soon. Bye.
Bye.